So yeah, we are talking about this triple glazed window that, as I said, is able to harvest the radiation from the sun in order to provide heat for the space heating or for the production of domestic hot water. And thanks to these technologies, then we can be able to harvest and to have also active part of the envelope, even when we talk about the treated surfaces of an envelope. At the end of this project, the aim of this technology is to reach TRL about 7. This is just a brief introduction of the concept in the working of this technology. So this technology is going to work in 2 conditions. The first one that is a winter mode, where the indoor air is heated up inside the window in order to provide warm air for the indoor ambient. While the second condition, the second configuration is the summer mode, where the aim is to produce warm or hot water to be used for domestic hot water purpose, or even if it needed for, let's say, kind of preheating for heat pumps and so on. So during the winter mode, we are going to heat up, as I said, the indoor air, while when we move to the summer mode, we are going to use the outdoor air, and heating up this outdoor air, we are going then to give this heat to the water and cycle circuit, turning on this pump so that we are able then to provide hot water for the needs. A brief presentation and description of the technology. So we are talking about, let's say, this technology that is mainly developed and manufactured by Digitech with the support of some partner regarding the automation of the system. The main aim of this technology, as I said, is to use also the glazed surface of an envelope in order to provide heat from the solar radiation. One of the main inputs that we have developed inside this project is to have an automated system control in order to provide the heat inside the room at the required temperature using a set point, so a thermostatic control. But at the same time, we are able to switch automatically from the winter mode to the summer mode, depending on the temperatures inside the window and the required temperature inside the room. The main innovation of this technology, as I said, is that we are able then to provide heat also using the glazed surfaces of building, but at the same time we'll be able also to reduce the demand, the energy demand of a building thanks to this triple glazed unit, but also we are going to test the impact of having this flow rate in the chamber of the window that can be even better in terms of insulation for the building. The potential of this technology, we think that is mainly for offices or terminal building, but in general, every kind of structure of envelope with a large grade surface. We can implement this technology both in public and residential building, and as well in case of retrofitting, so the renovation of old building, but also in new constructions. Digitech has already kind of developed a market trend for the starting from the next year in order to understand the possible value on the market and the request from the market for the technologies. Potential customers are similar, I think, to all the other technologies that are going and that has been presented inside this event. So mainly private building owners, but also social housing companies. And as well, I think that having a good interaction with architects and engineers can be probably the best way to introduce this technology in the market without the risk of, let's say, make the customer quite scared about the implementation. But with the help of architects and engineers, we should be able to, let's say, make this more easier for the final customer. As you can expect, the main benefits of these technology are related to the energy savings and therefore emission savings and cost savings. And I think that we have to think really about these kind of benefits, especially in this time where the cost of energy is getting quite unpredictable, but for sure we are going to expect a huge increase in terms of the cost. So being able to have a self-energy production could reduce also the risk in the future for, let's say, regarding the energy aspect. So this could be also one more benefit that starting from now we have to think about. Now let's move to more practical things. So how it has been done, the design and installation phase. Here I've just I would just like to show with you some pictures from one of the installation that has been done by Digitech. This is from their headquarters in Poland. As you can see, the installation of this technology is quite simple. It's kind of plug and play solution. In just, let's say, three steps, you are able to install this technology. So the impact on the comfort of the tenants is not so much. So in one day, they are able to complete the installation without any risk for the tenants. And then I will just like to focus on the real demo set of ENVISION, that is the Savona campus demo set, where the window has been installed for testing it. So here you have the external view, the internal view. As you can see, we have tried to maximize the glazed surface of the window, so we have quite different aspect. If we compare this to the other window that you can see, just I will like to show you here. So the other window are quite different, but in this case we wanted to maximize the glazed surface. We have just started this testing campaign, so just from March 2022, and we are going to end this testing campaign in September 2022. That is going to be the end of the project. So here you can see what we are, the behavior and the components of the technology of the window. So you can see on the left side the water circuit filled with the water and glycol that is going to be used in the summer mode, and also the pump that is right here inside this box. On the top part of the window, you can see the box where there is the control system, and then you can see the two grids in the indoor side. So the suction grid and the blowing grid. So the air comes into this grid and is blown from the upper part of the window. During the summer, as I said, the indoor grids are closed and are opened, the one in the outdoor part, so that we are going to recirculate the outdoor air inside the chamber of the window. In order to test properly all the performances of this system, we have also installed a sensor that you can see right here for evaluating the impact on the indoor comfort of this technology. So with this sensor, we are going to see if there is any impact, let's say, really in the reality on the comfort of the occupants of this room. Let's move now to the expected energy benefits that we hope to reach and we expect to reach with these technologies. So we expect to have something like 140 kilowatt thermal energy production per square meter when we talk about a south-oriented facade on an annual period. This leads, of course, at the same time to a saving of around 32 kilograms of CO2 if we think that this energy is usually produced by a gas boiler, a standard gas boiler. And we have tried to estimate which can be the ratio between the surface of the window compared to the surface of the building, the floor area of the building, in order to understand when this, let's say, the thermal consumption of the building could be, let's say, on a yearly basis, completely supplied by the window. And we have seen that this ratio is quite large, so that's why we suggest and we expect that the main exploitation of this technology can be used in very large glazed surfaces, something like terminals of skyscrapers and something like this. Then, of course, if we have energy benefits, we will have also economic benefits, and this is, I mean, what is important to share more with the customer, because sometimes they are more interested in the economic savings despite the energy. They don't have the same feeling for just energy saving and emission saving. So we have estimated the cost of around 300 euro per square meter of glazed surfaces for this technology, and so the expected payback time is around 23 years. That, considering that the lifetime of this technology can be expected around 25, even 30 years, this is quite a good result. But we have also to consider that if you're going to take into account also the increasing in the cost of the energy, probably this payback time can also decrease. But we have also to think about the impact that this energy cost can have also on the production of this technology. But we expect that the balances of the cost will lead to a reduction of the payback time. Just as a conclusion, so that I will just leave the floor for any question and about this technology. We think that having the chance of using this technology, this window, could represent a really relevant step toward the goal of have zero energy buildings, since that we are gonna be able to use also the glazed surfaces for thermal energy production. The aim of the test campaign that we are doing in Savona demo site is to have real performances on the field about this technology, and being sure that the expectation that we have from the modelization and the simulation of this technology are real also in the test campaign. So to be sure that what we are saying is confirmed by the performances on field. And therefore, we think that this technology can be really a great opportunity for the renovation of the target building that, as I said, in our opinion, can be mostly offices, terminals, and any kind of building where the glazed surfaces are very much larger than normal residential buildings.